fellow commentator who is from Australia, England, and occasionally Jamaica.
Alright, class, so, as you all know, our school has an old storage shed that isn't in very good shape, and they have asked us to figure out how we can figure out how much tin we need to re-tin it. So, the school's old storage shed needs to be re-tinned. How could we figure out how much tin we need to complete the job? And so here I asked, I believe, Scott a question. He answered it, and I don't remember what else was up there, but we got a bunch of other things. Yeah.
Pause. Okay, so the original set did not provide a very good example for those students who need a visualization. So instead, what we did was we incorporated 2 short videos about a stop motion video so students can actually understand how these structure breaks down into its 2-dimensional parts. Also, Mark is having a very tough time up here because he is not enthusiastic, therefore the class is right now sleeping. So now, we are going to rewind, stop, and play.
Alright, so good morning, class. So, as you all know, the school has an old storage shed that needs, well, it's not in very good shape. So we need to re-tin it, and the school has asked us to figure out how much tin we will need to do so. So, is there anything that you guys learned in grade 8 last year that could help us figure out how much tin we would need to do this? And now here I would ask the questions, and we're not actually going to get you an answer. So yes. Now, in order to help you guys out and visualize it, I have created these awesome videos to help you out. Okay, so now that you've watched the videos, you maybe got a visualization of how, of how you might be able to do this. I want you to keep in mind the question of how much tin, or how would we figure out how much tin we would need to re-tin the storage shed as this lesson moves on.
Pause. Now, if you notice here, the videos made the students more engaged with what the actual question was of how much tin is needed to build the storage shed. You also notice that Mark is more engaged with the students, and everyone seems to be awake in class and actually excited on how to build the storage shed. We will now continue with the original lesson.
Okay, so for this part, we're actually just going to re-show the original jing. One quick part of it, actually. So,
okay, so what I like to do is I like to break things down into shapes. So what are the shapes of this square cube? Okay, any more? So we got a square. Yes, you're right, Scott. There's a bunch of squares. Is there any other shapes other than a square? No. Okay, good. So there's just a square. So how many squares are there here? Think about it. Okay, you're right. So we have this front one, then we have its back one, then we have these 2 sides here, and then we have the bottom and the top. Sorry, the top. Okay. Are they all the same size? We're dealing with a square. Okay, so it'd be safe to say we could call this the base, so we have B, and this would be the same, so it'd be B as well. Correct? Okay. This is how we have it to look. Now, is there an easier way we could write this out? Okay, so yes, B squared. Now, how many times do you have B squared? 6. Alright, so what would we have here at the end? Okay, good. Alright, so that's what we could use. So the surface area of this cube would be equal to 6B squared.
issue that we have with this video is that it actually doesn't include a lot of mathematical language. He uses the phrase, what shapes do we see, or what shapes do you see in this square cube, which vocabulary correct is wrong because all cubes are square, as well as what shapes do you see that can get confusing for students. So we are going to change up the vocabulary a little bit. So we're going to have Mark redo that part of our development, and you'll see how we changed it. So yeah, keep an eye on how he rephrases and the words that he actually uses.
Okay, class, so we're going to start by trying to figure out how we would determine, or how we would tin a rectangular prism. So where would we start? So I would ask that question, you guys would answer. And then I would proceed by saying we need to determine the areas of all the sides of the rectangular prism. So let's first determine the shapes of the sides of the prism as a review. So what shapes are the faces of the rectangular prism, and how many are there?
Pause. You need to pause.
Well,
Pause.
Okay, so what you're going to notice here is you're actually going to see how, first of all, he talks about the faces, so the shapes of the faces. He's not just asking you what shapes you see, because like we said before, that can get confusing for 9th grader. So he actually does talk about what the actual shapes of the faces are. So that's really important. The next thing that he actually talks about is the quantity of them, which again is very key in here, because in the original he just said, well, how many of them are there? And students may not recognize that they're looking for how many faces there are. And the other thing to notice is we actually changed from using just a plain cube to actually using a rectangular prism, because a rectangular prism is actually, a cube is one type of rectangular prism. Now in this case, the other reason that we use the rectangular prism is because it actually comes up in our storage shed. So our storage shed is actually made up of at least one rectangular prism. So that's really important. Now the next thing that we would typically go through is actually run through this actual example. So we'd run through an actual example with this. So first we would have broken it down into its faces, and we would have determined that there were 2 of each kind of faces, and there were 3 faces in total. And then we would have actually tried this example, and these dimensions are actually the dimensions of our original storage shed. So that's important. But yeah, and eventually we would derive a general formula, a relationship that we found in here, because we do think that is important that students do have that knowledge. And because this is part review, because they should see the surface area of simple figures, not composite figures, they should have seen that in grade 8. So this theoretically should be a bit of a review. Okay? So let's continue. So now we're going to show you guys again, we're going to show you the second part of the jing.
Next example. How about this? We have a pyramid here. So what's the first thing we want to do here? We want to break it down into shapes, right? So what shapes do we have here? We have a triangle, and we have, a square. Pretty good. Okay, so with prior knowledge from, all my great teaching in the past, have I taught you guys how to find the area of these 2 objects? Okay, so the square. So how do we do this one again? The square. We just did. Okay, so we got these squared. Okay, which like we said, is b squared. So that one kind of simple. How about the triangle? What do we do for that one? Great. 1/2 times base times the height. Now, how many squares do we have? We want to find out how many of each object we have, right? Okay, we got 1 square. All right, so we can.
Okay, I'm just going to pause it there, and we'll have Skylar take over.
Okay, so we want to first notice that his language hasn't improved yet. The second thing that we want to notice is that he used a pyramid in the situation. With most storage sheds, we don't actually see a pyramid being the roof of the storage shed. So let's see what Mark does next. So we're first going to rewind past this jing, and then we will see what Mark does. So play.
Okay, so class, now here we see a triangular prism. So we are going to do the same thing with the triangular prism as we did with the rectangular prism in order to find out how much tin we would need to re-tin the triangular prism. So, I would ask the question, how does the triangular prism differ from the rectangular prism? And then you guys would answer, I would respond. And then, how is it the same as the rectangular prism? Same thing, you guys would answer, I would respond. So, what do we need to find the surface area of the triangular prism? And then I would, they might shout out some answers, and I would tell them they have 3 minutes to complete that on a piece of paper with partner, whatever, in the clock.
Pause. Notice here that now we've used a triangular prism rather than the pyramid. This is much more relevant to the storage shed because we see triangular prisms in the storage shed. We see that his vocabulary has also improved. Furthermore, we're going to continue, and Mark will develop a generic relationship of the triangular prism. Now, because we do not have time for this right now, we're going to just fast forward past that part, and he will continue on with his lesson. Fast forward.
So yeah, so then I would, we would actually work through this problem.
Not one. This is the original.
Oh, this is the original one?
Yeah.
Okay, so in the original lesson, I actually did this problem with Scott and I can't remember. Scott and Skylar. And yeah, we broke it down into shapes. We added them together and found the formula, or we used the formula to find it. It was really rushed in the game. That was pretty much the gist of it. And then I gave them this question to work in with a partner or a group of 3. So to find the surface area of the school storage shed and hand in their work, and the dimensions were given here.
Pause. Okay, so overall this portion of the lesson was, we thought was quite well done. What we did is we basically took the that example that you saw here, and we actually had thrown it into the development earlier. So that was basically what we did. Now we did update the dimensions. We actually used the same dimensions that we will have for our actual storage shed, so that was actually something we did different as well. So yeah, so now we're going to rewind, and we're going to actually replay this part of the development the way that we want it to go. Rewind.
Okay, class, so here we have the old storage shed with its dimensions. As I told you at the beginning of the class, I wanted you to think throughout the lesson of how you could figure out how much tin is needed to re-tin the storage shed. So you are going to get together in partners, and you are going to work at finding the surface area of the shed. And as this is going on, I would circulate and ask these questions. How can we tin the shed? Can we just add the surface areas together of a rectangular prism and a triangular prism? Why does this method not work?
Perfect. All right, so just take note of how we developed some questions for Mark to use while he's circulating the room, while these groups are being made, because this part is the key part. The actual outcome is related to composite figures and finding the surface area of composite figures, as well as what he just mentioned about how you can't just take the separate composite figures and add their surface areas, the single figures and add their surface areas together and get a composite figure, because that's not going to work, and we can see why. So yeah, finally, Mark's original lesson did not have a closure, so we actually did add a closure, and he's just going to run through that really quickly.
Okay, class, so now, as for homework, I want you to go home and look at these questions for no more than 7 minutes. No more than 7. Set your timer. Nothing. So, what if I added a door which is 1 meter by 2 meters and 2 windows measuring 1 meter by 1 meter. How much tin would you need? Intuitively, do you need more or less tin? Does it matter where the door and the windows are? Have a great evening.